Hey folks, welcome to my channel Number Pen. So there we have the problem on the screen. Integrate the following with respect to x. We have 1 divided by square root of x square plus 4x plus 2. So what we've been given is dy by dx and we've been asked to find y. My y is nothing but integral of the given expression. So let's write down what our y is. My y, now I can see that my y is not in a very simple format whose antiderivative I know from first principles, and I will have to apply one of those techniques that I have learned in my recent videos, right? So we have dx in the numerator, and in the denominator I have a square root, and within the square root I have a quadratic expression, right? So what you need to do whenever you see a quadratic expression is try to express it or bring this particular expression, quadratic expression, of the form, x plus or minus a the whole square plus or minus b square, right? Where a and b are constants. So that would be our step one. And then step two would be to make the necessary substitution for us to simplify the given expression, right? So let's simplify and re-express the quadratic expression in the format which I mentioned just now. So I'm going to pick only the quadratic expression what I have inside, and let's do a bit of working on that. I have x squared plus 4x plus 2, and my x square I retain it as it is, but my 4x I'm going to write it as a 2 times 2x, right? And then I have a plus 2 here, right? So I know that my a plus b the whole square equals a square plus b square plus 2ab, right? So if I add a 4 and I subtract a 4, which doesn't change the expression, and I still have my plus 2 out here, and I combine the first three terms here, what I've written, and let me highlight it in yellow. I have an x square plus 2 times 2x plus 4, and my 4 is nothing but a 2 square. So now I have an x square plus 2 times 2x plus 2 square minus 4 plus 2. Now the expression which is highlighted in yellow is nothing but an x plus 2 the whole square, right? I hope you folks are with me. Again, the formula that we use here is from algebra. A plus b the whole square equals a square plus b square plus 2ab, right? So what we do is the portion of the expression which is highlighted in yellow is nothing but an x plus 2 the whole square, and then I have a minus 4 plus 2, which is nothing but a minus 2, right? Again, like I mentioned earlier, any quadratic expression you have an integration of this type, try to express it in the format x plus or minus a the whole square plus minus b square, right? So here you have a x plus 2 the whole square minus 2. So I'm going to rewrite my minus 2 as root 2 the whole square. So we have this expression as x plus 2 the whole square minus root 2 the whole square. So that's the quadratic expression in the format that's going to help us solve this particular problem. Now I go back to my y, and I'm going to rewrite this as, let me do it here itself. I have my y equals integral of, again I open my x by y format, and inside the square root I now have x plus 2 the whole square minus root 2 the whole square, right? And what is going to help me to integrate this, right? Now I'm going to do two things out here, right? One is I'm going to make the first substitution t equals x plus 2, because I'm going to bring it to the format, dt by square root of t square minus a square, right? And you're going to be able to do that pretty easily with this particular substitution. Dt equals dx, because my t equals x plus 2. Now I put back everything in terms of t. What do I get? Now y becomes equal to my dx, which is there in the numerator, is a nothing but a dt, and my denominator, which is square root of x plus 2 the whole square, what does that become? So my x plus 2 is nothing but t. So I write my first part of the expression inside the square root becomes a t square, and my second part is nothing but a square root of 2 the whole square. This is what I have: integral of dt divided by square root of t square minus root 2 the whole square, right? Now, in my recent videos, we solved expressions of the type integral of dx by x square minus a square, or dx by a square minus x square, which we resolved using partial fractions, right? And that was pretty much simple. Now here, I don't think you can resolve this using partial fractions because you have a square root term in the denominator, unlike some of the previous problems what we solved, right? So the best way to solve this particular problem is by making an appropriate substitution, right? And we'll have to figure out what is that substitution that we can make, right? So I have t square minus root 2 the whole square, right? And I want you folks to connect this with some of the trigonometric identities that we know, right? We know that my sine square theta plus cos square theta equals 1. Secant square theta minus tan square theta equals 1. The substitution that will help you out here is E equals root 2 secant theta, right? And as you do more and more problems, you will understand where to use sine square theta plus cos square theta equals to 1 identity and connect it with the expression, and where to use your secant square theta minus tan square theta equals 1, right? So in this particular case, once we make the substitution, you would understand why we are doing this, right? And I will also make it a point to explain it as we run through solving the rest of the problem, right? So my t equals root 2 secant theta, which means my dt equals root 2 times secant theta tan theta d theta, right? I expect you to know this from the lessons we had in differential calculus, right? So I have my dt root 2 times secant theta tan theta d theta, right? Now we have our t in terms of theta, we have our dt in terms of theta. So let's go back to our y and express everything in terms of theta, right? So my y becomes integral of my dt is what we worked out just now. And then got a little bit of work to do in the square root term in the denominator. So let me open my square root. I have t square, which is nothing but a root 2 secant theta the whole square, right? I hope you folks are with me. Let me highlight this in yellow, right? So what happens to my t square is I get a 2 times secant square theta. And then I have a root 2 square, which I will call it as a 2, right? Now you see, I can pull out the 2 inside the square root, right? And I can cancel it out with the root 2 in the numerator. So that's point number one. And point number two is inside the square root in the denominator, I have a secant square theta minus 1. And what is that? That's nothing but a tan square theta, right? So when we rewrite this expression in the subsequent step, I can cancel out my root 2, which means I'm left with a secant theta tan theta d theta in the numerator, point 1. And then I have a square root of secant square theta minus 1, which you folks are quite familiar with because my secant square theta minus tan square theta equals 1, which means my secant square theta minus 1 equals tan square theta, right? Which means I'm left with the square root of tan square theta, which means I will have a tan theta, right? I hope you folks are with me. And in case you've not understood any of the steps that I've done so far, please do, mention in the comments, and I'll be happy to respond back with providing the appropriate clarifications, right? So now I have a secant theta, tan theta, d theta in the numerator, and I have a tan theta in the denominator. I can cancel out the tan theta, and what I'm left with is y equals integral of secant theta d theta, right? Now, this is something that I would recommend you remember this as a formula, otherwise, you will end up spending a lot of time trying to solve this in the exam. And we have done a separate video on how to do integral of secant theta d theta, and I'll probably give a link to that particular video as well in the description. Kindly take a look at it. And I'm going to directly apply the formula out here. Integral of secant theta d theta is nothing but log of mod of secant theta plus tan theta, and then I have my constant c, right? So now, my original question, everything was in terms of x, right? And I made two substitutions trying to solve this problem. The first substitution that I did was, let's go back and see what the substitutions that we have made. One is, I did this substitution, right? T equals x plus 2, and let me highlight that for you folks. And the second substitution, which is already highlighted in yellow, and then we again made a substitution, t equals root 2 secant theta, right? So I'll have to put back everything and represent everything in terms of x, right? Now that's the next step we have. So to start with, what I'm going to do is I'm going to put back everything in terms of t first, and then I'm going to replace my t with the substitution x plus 2, right? So let's do step one, which is putting back everything in terms of t, right? So my log of mod of my secant theta is nothing but a t by root 2, right? Because my t equals root 2 secant theta. So that's my secant theta. Then I come to my tan theta. So my tan theta, maybe I will do this separately. I'll go to the bottom of the screen and help you do this. Tan theta is nothing but, we know the trigonometric identity, secant squared theta minus tan squared theta equals 1, right? So what is my tan theta? My tan theta is nothing but a square root of secant squared theta minus 1, which is nothing but a square root of, I know what is my secant theta, it is a t by root 2, we just did that now. So what happens to my secant square? It is a t square by 2, right? And then I have my minus 1 out here. So my tan theta is nothing but a square root of t square by 2 minus 1. And therefore, when I go back and put it back in my y expression, and then I have my mod sign and then my constant, right? So that's my y in terms of t, and we're not yet done. And you remember that we also did one substitution in the beginning, which was nothing but t equals x plus 2, right? So what I do in the subsequent step is I'm going to put back my y in terms of x, and I will be able to arrive at my final answer, right? So what is my t by root 2 is nothing but an x plus 2 divided by root 2, right? And then I come to my second part, which is, you know, square root of t square by 2 minus 1, right? So this part might need a little bit of simplification. So what is my t square by 2 is nothing but an x plus 2 the whole square by 2 minus 1. So let's not make this portion of the screen clumsy. I'm going to go down and again resolve this for us. My t square becomes x plus 2 the whole square, which is nothing but an x square plus 4x plus 4, right? So I can write that as it is, and then I have a divided by 2, and I get a minus 1 out here, right? And I know that if I'm going to make the common denominator for the expression inside the square root as 2, what do I get? My entire expression will become x squared plus 4x plus 2 divided by 2, right? So my square root of t squared by 2 minus 1 is nothing but square root of x squared plus 4x plus 2 the whole divided by 2, right? So all that I need to do is copy this and put it back out there. So there we are. And can I do any further simplification? And if you'll be able to appreciate this, if I write this in a slightly different format, right? So I can write this as log of mod of, and you see that I have a root 2 in the denominator, which is common to both these expressions, right? And then I have an x plus 2 plus square root of x square plus 4x plus 2, right? I know that I have an expression in terms of x in the numerator within the log, and then I have a root 2 in the denominator within the log, right? So can I do some further simplification? The answer is yes, because I know that my log of a by b is log a minus log b, right? And in this particular case, my a is this expression x plus 2 plus square root of x square plus 4x plus 2, right? So let me highlight this in a specific color. So let me use turquoise. And then my denominator is a constant with, let me use a different color, say green. So which means when I use the log a by log b formula, all that I will get is a log of mod of, right? And then I will have a minus log of root of 2 plus c, right? Now I can combine the log root 2 because that's also a constant, right, along with the c. So my answer to this problem is log of mod of x plus 2 plus square root of x squared plus 4x plus 2 plus c, right? So let me highlight my final answer in pink. So there we are. I hope you found my content useful. Please do subscribe to my channel and support. Thank you.